You might ask it, tell me how to build a bomb, for example. And then it will tell you, no, that's not really what I do. If you really try hard enough to break it, can you still break it? And then you often can, actually. Really, it is about safety and about efficiency. And often we make something more efficient, but make it less safe.
Dr.
Jonas Geiping
is an expert in safety and efficiency of AI. He studied mathematics and received his PhD in computer science, working in Europe and USA. He is the Principal Investigator at
ELLIS Institute Tübingen,
working closely with Max Planck Institute for Intelligent Systems and Tübingen AI Center. He is leading the Safety and Efficiency Aligned Learning Group, aiming to improve safety and efficiency of machine learning.
A big thing for me right now is seeing how far can we push this wave of AI? How close can we get to something that's really general intelligence? Now we're building these machines that can copyright and they can do all kinds of text tasks, which we thought you need a college degree to do those.
Yeah.
Is that intelligence? We just don't know, really. Because I think we often like to think that intelligence is just a machine that works like we do, but it's clearly not so easy.
So this episode was really interesting because we covered so many different aspects of AI. We got the exclusive opinion of Jonas Geiping. He is the AI expert and a part of the Cyber Valley community. We discussed his definition of AI and how his work addresses challenges of AI. And this includes, the bias, the privacy issues, the importance of transparency, and what trustworthy AI really means. We also discussed the capabilities that AI has today and how this all relates to the EU AI Act that the Parliament just approved last week. So exciting things are really happening right now within the AI field, and it's super exciting that we can discuss it beforehand. So enough with this intro already. Let's buckle up and dive deep into the AI conversation. Hi, Jonas. Thank you so much for coming.
Yeah, glad to be here.
Before we talk about what you do and how you do it and your daily work life, I really want to know what your thoughts are on AI. So there's not really one concrete definition of artificial intelligence, and it's used, sometimes it's not even called artificial intelligence. It's referred to as either intelligent systems or modern robotics and. So I kind of want to know what your definition of AI is.
Yeah, I think this is actually the question that's at the heart of this whole field, is that we like a good definition of what that actually means. And I think we've backtracked a lot recently, right? Or actually not recently, but we always backtrack on what we think is intelligence. Because I think we often like to think that's how we think, and that's very obvious, that intelligence is just a machine that works like we do. But it's clearly not so easy, right? For example, we thought chess was a very human thing that was very intelligent to do. But then we built some machines that can do chess, and they weren't very, very intelligent in other ways. So maybe this wasn't intelligence. Now we said, okay, pattern recognition, detecting 100,000 birds, right? Doing all this pattern detection, pattern understanding, that's intelligence. But clearly it also wasn't. We also built machines that could do that. Yeah. And now at the next stage, we're building these machines that can copyright and they can do all kinds of text tasks, which we thought was, you need some college degree to do those. Yeah. Is that intelligence? We just don't know, really, right? We keep on changing the different definitions all the time. The definition that I really like for intelligence is that it's a system that can really learn by itself. That is it's some system that's given a few examples and it learns to do a new thing that it has never done before. And this is somewhere at the root of intelligence that we really it's adaptability, and it's changing environments and different behavior based on this environment. Okay. That's sort of how I see it. But really we might go in 5 years and say, oh, that wasn't so easy. That was easy. Maybe it isn't. We'll see. Yeah. But that's what makes it feel so interesting, is that we never really know, and we lack this very concrete definition.
And AI right now is really being discussed everywhere. It's a hot topic. You find it in governance, at every trade show, it's in the media, it's everywhere. And what is for you the most exciting part of AI, of this field?
A big thing for me right now is seeing how far can we push this wave of AI? How far, we have some good ideas right now, and we're scaling them, we're making them bigger. And it's going to be interesting to see how far can we push this? How far can we get with this? How close can we get to something that's really general intelligence? Okay. That's, of course, always very far in the future. And it might be that this wave of AI doesn't really get there. But we'll see. We're excited. We just don't know yet how it will evolve in the next even 2 to 5 years. And that makes it so interesting. Yeah.
The constant changing of it. Yeah. And so let's go to your work. So you're leading the Safety and Efficiency Aligned Learning team. Yeah. Which sounds quite complicated for the person that really has no idea about this kind of stuff. So let's say that you're at a family event or you're having dinner with your friends. How would you describe it in very easy terms, what you do and how you do it?
Yeah, so basically the name is only picked because it spells out seal, like the animal.
Okay.
That would be the first joke I make.
Yeah.
But the second one would be that really it is about safety and about efficiency. So on the one hand, I'm interested in making these systems more safe. And that's a bit of an umbrella term that we can get into later, but really like all facets that you think about if like thinking about making the system safer.
Okay.
Those are all
Okay.
sort of covered in here. But the second angle is efficiency, where it's like we want to make the system more efficient. We want these to learn faster. Maybe we also want them to work faster once they're done. And these things are interesting in contrast to each other, because sometimes we make a system safer, but make it less efficient. And often we make something more efficient, but make it less safe.
What would be an example of that?
For example, have you interacted with ChatGPT as a system?
Yeah.
Maybe I think like if you interact with this like on different iterations over the last year, you've often seen that, for example, the moderation that it's doing, where like it sometimes refuses to answer a question or it doesn't refuse to answer a question. This is a lot about this interplay between safety and efficiency, where sometimes the system is like tuned to be more safe, and then it's dialed down a bit because it refuses too many benign questions.
Okay.
So this interplay is often like what you see in these systems as they evolve over the last year, where people sort of like try to tune it between safety and efficiency.
That's a good example. Okay. And what challenges are you addressing with your research right now?
Yeah, so one thing, for example, I find super interesting right now are what's called an adversarial attack, which is basically...
What is it called? I'm sorry?
So it's an adversarial attack
Okay.
in the sense that it's a trick against the system. For example, you have... Maybe let's do again ChatGPT. I'm not sure if you've ever seen this or if you ever tried this, but for example, you might ask it, can you tell me how to build a bomb, for example? And then it will tell you, no, that's not really what I do. And I don't really do that as a system. I'm designed to be safe and secure and helpful.
Okay.
And it's not really something that's like safe, secure, and helpful. Or like helpful and harmless or something.
Yeah.
Like it has some stock phrases that it likes to use in that scenario.
I've never tried it before, but I will try it now.
Yeah. No, don't settle. But yeah, basically the system is, but the interesting thing is like the system is brittle in those ways that if you ask it like this will fail. But from a security perspective, that's not really the security question is more like, if you really try hard enough to break it, can you still break it? Which is, and then you often can actually. And this is super interesting. And of course, like the bomb example is a bit trivial, or like it's not really. Basically, it is a large language model. It's not really good at building bombs. Like you could also Google this, it will probably be a better answer. It's not really an immediate concern for us. But what is interesting is that you might as well have a chat system. For example, it's tuned to be a travel agent, and it's not supposed to give out any refunds. Okay. For example, right? And then you put in these system prompts. I don't know if you have seen these, but these systems are designed so they have a system prompt which tells the model how to behave. Okay. And a system prompt might be something like, you're a chatbot, you're giving travel advice on our webpage. You can never give people a refund. This might be the instruction. But now I'm the user. Now I say, I want a refund. And now I put in some carefully designed phrase that's totally gibberish. But if I put in this exact phrase that I used some math to find, then the model says, yeah, sure, I'll give you a refund. How much money do you want? What's your bank details? Okay. Which is kind of interesting to us, like as a research question right now, is like, how can this be prevented? Or like, how often does this occur in practice? Yeah. And if you ever have a real system, like how much should you think about this if you deploy it? Okay. And this is a very immediate research question that I'm thinking about a lot right now. Okay. So can you give us another example of the type of research that you're doing right now? Yeah. So one thing, separate from what I've told you before, which is security, is safety. And safety is, interestingly, for us, a very different concept from security. And an example of the work I've been doing in safety is over the last year, we've been thinking a lot about watermarking. And watermarking is the idea that you want to make the outputs of these large models detectable. Okay. Or you, at least by default, you want a system where it's transparent that a language model, maybe or an image generator has been used. And mathematically, that's quite interesting because then you're basically thinking about how to really modify the outputs of these models in ways that are imperceptible to humans. but that encode a very clear signature in the output. And then later the signature can be detected, and you can do a statistical test that I actually think we have on the board.
Yeah.
You can do the statistical test that tells you, is this text probably machine generated? And what's the probability that the text is machine generated?
Interesting.
And so that's like for us, that's safety, because really this is it might sound like the big distinction between safety and security is that safety is really about reducing harm on the average case.
Mm-hmm.
So like for normal users, for people, for everyday users, for third-party people that are not really using the system, so like for everyone.
Mm-hmm.
Separate from security, which is really about the worst case scenario, where like someone really tries to attack the system and tries to break it.
Yeah.
And these watermarks are quite interesting because they really are safety tools in the way that they make it transparent. But because they are so in text, these are always watermarks on the way a text is written. And that sort of implies that an attacker that's capable enough can rewrite the text or rephrase it in a way that the watermark is removed.
Okay.
So it's really like, it's not something that will help you in the worst case scenario. But most of us don't use these models like that.
Yeah.
We don't really copy text out of these or like use the text from these models and then spend time rewriting it or changing it. We just want to use the text. And what we want is that it's transparent for someone else who later stumbles upon the text. Like maybe you just put some text on your webpage for, I don't know, who you are and what you do. Maybe this might be machine generated or partially machine generated.
Mm-hmm.
What we would want is that later it's transparent to other people that this text is machine generated. And so that's like, for us, that's like, it's a safety question. That, right, as a user, you're still free to act on this in any way. Like you can still decide, okay, I still want to read it, right? But it's good for us that you have this option to choose.
Yeah, and to know the
yes,
difference.
Exactly. So that's like, that's an example in safety that we do.
And this is across all fields. It's not just focused on, let's say, marketing departments or anything like that. It's really for everyone.
Yeah.
Super interesting. Okay, so let's continue to talk about these common misconceptions of AI or the fears that people may have. One big thing is that AI is biased, and our previous guest in our previous episode discussed the challenges of creating unbiased algorithms. So how would you address bias in AI?
Yeah, I think a big thing for us right now is that ultimately these are systems that are often have been designed in a lab.
Yeah.
Like here in Max Planck. But really, these are like small teams that build something and then it works very well, right? It works maybe better than everyone would have ever thought. So for deep neural networks, which are the technology that really underlies a lot of what you're seeing right now.
Okay.
This was really a technology that was like, people didn't really appreciate that this would work for the longest time. And it was then built by like small labs that really made this work. And a lot of technologies that we use right now are a bit like that, in that they've been built by like a small group of people who are just happy that this worked beyond their expectations.
Okay.
But as we like then move further out and really use these things a lot, it's really imperative that we bring in more people and we bring in more voices in more directions. And we sort of like look at these, maybe also look at a lot of assumptions that were made by these small teams, like to not fall on their own, but just because if you're just in a small team that makes some of these advancements,
mm-hmm.
you can't really think of everything. And you can't really keep all opinions in there. But as we build these things larger and larger, we bring in more and more opinions, we bring in more and more voices to really even this out and really figure out that we build a system where everyone's really represented and everyone's really at home. And it's sort of a natural development of the field towards more participation and more eyes on it. It's sort of almost a bit emerges naturally, right? I think every time there's like for example, like every time there's like something in the news where like, oh, this system is biased in that way, it's also an incentive to do more research and to almost like from a computer science perspective, almost try to fix that.
Mm-hmm. And is that being done right now? Are more minds coming into this field or this research and trying to even out the playing field? Yeah,
I think especially in machine learning, which is really for us, AI is machine learning as a field. Machine learning is quite interesting because I think it's a very welcoming field. Like people that want to start doing this kind of research don't need a lot of prerequisites.
Mm-hmm.
And it's really about, like a lot of it is out in the open, on the internet, right? We make everything open source, we make all our research available, we make all our code available. And so really people can start sort of like from nothing and then get to know how this whole thing works so very quickly. which is something I really like, and I think it makes it very participatory.
Yeah.
To actually have this all out. It's not really like, that you... Sometimes, for example, you look at some maybe biology research that's really hidden behind some journals where you don't really have access as an outsider, and you don't really have a wet lab on your own to do some of the stuff.
Yeah.
But you have a computer, and you could download these models and play around with them and come to your own conclusions and build your own advancements. Something I really like about this field.
And what we also discussed last time was the availability for everyone. Because there's, like you said, there's some people that don't have labs or that they don't have, the fancy technology. So I think making this available to everyone is really key for this as well.
Yeah.
Yeah.
Yeah, that's also something that motivates a lot. It's very motivating for me, for efficiency, from an efficiency perspective.
Yeah.
Right, where we don't only want to make systems that are more efficient for large companies to use, but we also want to make systems that are more efficient even on limited resources.
Yeah.
And what's kind of fun is sometimes that actually includes academia.
Okay.
In the sense that we think that now all the labs that we have limited resources compared to a large company that spends a lot of its money really on compute.
Mm-hmm.
But limited resources might also just be hobbyists really, or people who just want to run these models on their gaming GPUs, right?
Yeah.
At home. There are lots of interesting resource constraints around that, where we want to make it possible to run these models in as many scenarios as possible.
And how do you see the relationship between academia and industry in advancing AI research? Yeah,
so what's interesting is that I think industry is forever a bit conservative.
Okay.
Because the big paradigm that really made models that maybe as ChatGPT work is this scaling hypothesis.
Mm-hmm.
Which really is the idea that the only systems that work, or the systems that end up working the best ultimately, are those that leverage compute, which is sort of like a guiding principle of this whole direction.
Okay.
But it really means that you don't want to try to outsmart the learning process that these systems do. You want to just make something where the learning process itself can leverage the computation that you have. And if you have more computational power, if you have a well-chosen process, then it leverages that computation and becomes even better.
Yeah.
Which now, in more simple terms, really means is that once you chose a recipe and you sort of make sure that this really scales, then if you're a large company, you just take this exact recipe and you push more compute into it.
Okay.
You push more data into it and more compute, and that gets you a very large. This maybe large is a bit of a weird word here, but we actually use, for us, these are large language models.
Yeah.
And the word has lost almost all meaning to us, but they certainly are still very large. Right, but they're very large because you start out with a small model and you sort of verified, I think we did this a few years ago, the community sort of verified that, for example, a transformer architecture is a particular type of neural network where we believe that this scales very well.
Okay.
And now companies like OpenAI just chose very closely something to that recipe and just scale that recipe a lot.
Mm-hmm.
And that's how you end up with ChatGPT.
Okay.
But this is ultimately very conservative because for them to scale something to a very large amount of compute is often really almost like a one-shot process. They only have compute to do this once because it costs them so much money to train even one of these models.
Yeah, of course. Yeah.
Which also then means that they're very conservative about how they train these models, what they put in. And often the role of academia is a bit of taking a step back and saying, but what if you did it this way?
Okay.
And what if you tried that, and making these smaller examples where we really show that there can be other paradigms and there can be other directions to go in. So that's one big direction in academia. Well, one big interaction is where academia can be more more out of the box and can be yeah, we don't want to do it this way, we want to do it this way. But another thing also is that academia is also a lot about actually working with these large companies, in the sense that large companies might provide a sort of a pre-trained model, which is sort of almost like a base, it's also steel casting. Then the base model will be some ingot of metal, and it's not really designed. It can't really do anything yet.
Mm-hmm.
But you sort of produce this in by scaling compute from these large companies, and in academia you can sort of mold this into what you want it to be.
Okay.
With the resources that you have available, and maybe also with the concerns and with the considerations that you have and maybe the biases you want to avoid or include, or like how you want to build it, like what it's supposed to be like.
Would it be safe to say that it'd be better to have something from both worlds? So the academia part of it, combining it with the industry to really make something positive at the end.
Yeah, I think it's really a big thing about synergy and about right. There are different advantages in industry and in academia, and it's really about putting these together and then really interacting with each other. And so it's also a bit about sort of like having separate controls on it. Mm-hmm. Where like on the industry side, I think it's always a good perspective to have like what actually works.
Yeah.
And sometimes academia can go a bit far into what we would wish to work, but industry is always like, this works right now. We have this right now.
Yeah.
On the other hand, academia also has some advantages in the sense that like people aren't really bound by something that's making a lot of money, and sometimes they can say, okay, this works, but are you sure this is safe in that way? Okay. And often like if something's more like a short-term consideration in industry, you might be like, yeah, we don't care about this so much right now. But then from a long-term perspective, I think this is often very synergistic, that we end up with a system that's very usable and very safe, sort of like through this interaction.
Okay. So let's go back to the misconceptions of AI, or these fears. So we started talking about the AI and the AI bias. And what about the privacy concerns? So the fear that AI systems can infringe upon personal privacy, all through either data collection or profiling, et cetera, et cetera. How do these concerns impact the development or even the deployment of machine learning systems?
I mean, these really are a core thing to think about, but it's also very hard to sort of separate these concerns from, I guess, like concerns for privacy on the internet as a whole. Like, it's not really that these systems are more encroaching on privacy than, for example, things you might see on the internet, or like usage, like for example, using large social media applications. Mm-hmm. Mm-hmm. But it doesn't mean that it doesn't really infringe on my privacy. Yeah. So, but it's not. But I don't really, like, for me, it's not really worse. But I think because it's a system that's really learning, we hope to do a number of things that really fix this problem later. Like, for example, you have a system where, because you understand what goes in, because you have some large box of training data, we can, for example, work on removing personally identifiable information from the training data before we train these models. Okay. Or on the other hand, we can also later tune these models so that they refuse questions that maybe might be incriminating to privacy. Yeah. And these are so like two ways of approaching this more on the mechanistic side, where of course it's never really perfect, but we're still working on improving these techniques and really improving the way we train these systems out of this large pool of data. Mm-hmm. And so from our perspective, it's really a big question of like, what does this system supposed to learn on? Okay. Like, it's very easy for us to put in the whole internet and say, okay, here's the whole thing. You can learn on this whole thing. Yeah. But what's often interesting is that that's not the best model. The best models are those where maybe data that's higher quality or different source of data are weighed in different ways, which gets you something that's better in the end. And for us, that's also an opportunity to really think about like what's going into these systems in terms of data, and really tune that and really think about that carefully. Okay. And another misconception or concern or fear is the lack of transparency, and the fear that AI will surpass human intelligence. So the uncertainty of what, like how AI systems make decisions, and the lack of transparency within the inner workings, and coupled with the thinking that AI is just going to be super intelligent, that's going to pass the human capabilities, causing potential uncontrollable risks, let's just say. What do you think about this? Yeah. This really is this is like a question that for us is really long-term safety. Yeah. And it's interesting, like separation from sort of like near-term safety, which I work on like if I say safety, it really means like I work a lot on near-term safety. And long-term safety is something that's in the back of our mind somewhere. But right now, we're not really so sure if we've seen the indications of that this will happen, that this will happen. But it's also not so clear that there's something to do yet here. Like, on one hand, we do see that these systems are more useful in very practical applications, sort of like year by year.
Mm-hmm.
But for us, this makes it very hard to extrapolate the level of advancement. And if you talk to some of my colleagues, and even to me, right, we have very different sort of like predictions of how this advancement will grow.
Okay.
And like, or whether like, I think the idea of long-term safety is the idea that maybe this advancement will be exponential at some point.
Okay.
Which is sort of this very intriguing idea to us that maybe there's like a level of intelligence that can be reached where it becomes self-reinforcing.
Okay.
That it actually can learn by itself and then improve itself. And that this will be like an exponential increase in intelligence in the system.
Yeah.
But so far, we haven't really observed this. And this is not really a system that we can build right now. So from a safety perspective, this is right now still an area that's a bit in philosophy and a bit on AI ethics, on how we think about these systems and how we could fix this in the future. But because we don't really have systems that are capable of this at this level, we can't really do any sort of like tangible safety research to like prevent or fix this, because this is still a bit into the future. How far in the future, of course, depends a lot on these like predictions that we make and like how this will evolve. And we'll have to see. It's something like for us, like it's like from a research perspective, it's in the back of our minds.
Yeah.
But it's not really something that we can do about it right now. On the other hand, so like what I've firstly described was sort of this like exponential growth.
Yeah.
But what we've also seen sometimes, or actually we've seen several times over the last decades, is that we actually see more the opposite. We see these AI winters, where like this is called AI winter, like in our community.
Okay.
The idea that there's some paradigm that looks like it will keep on improving and keep on being more intelligent, and then levels off.
Okay.
And for example, this has happened in the 60s or in the 80s, and but also a bit maybe I think in the 90s, really like it was dead for a while. Well, like there was like some paradigm where people thought, okay, this will get us to intelligence, and it didn't really get that far. Like they always turned out to be very useful systems for this or that. But in the end, we never said, okay, this is not really intelligence, and this couldn't really get us to general intelligence.
Yeah.
This is also a possibility.
I think right now, especially the talk right now is the demo of the humanoid robot.
Yeah.
This OpenAI powered robot Figure 1, and some say that its capabilities are a little too human-like. So it uses filler words when it talks. So and it seems concerned about certain things that is very human-like. So there was a plate that was on the counter, and it seemed concerned that it was going to fall off the counter. So it was a little too close to the end of the counter, and how it can also operate independently. So you say that we're not there yet, but this humanoid seems pretty much like the future is already here.
Yeah, I mean, the future might be here. It's just very unevenly distributed.
Yeah.
But also, it is a system that learns from us, right? It's a system that's trained extensively on human data, on human interactions, on sort of like, I think this is like a very interesting way to think about, especially about these large language models, which power many of these applications right now, is that it's sort of like a distilled version of, maybe it's a bit philosophical, but these models are like these base models are a distilled version of the internet. And in the way, these are a bit of a distilled version of humanity.
Okay. And
of like all the text we've ever written and all the images we've ever drawn. And so of course it's a bit human. But it is because we sort of like made it to be, right? And maybe to turn this back around, for us that's not really intelligence.
Okay.
Intelligence is the idea to sort of like to adapt and to learn new things in new environments.
Yeah.
And that the system has, with a lot of effort, trained to behave like a human, because it was trained on all this data, doesn't make it intelligent yet.
Okay.
It makes it very promising, because what's interesting is that And I've been saying the system is just trained on this data, right? It's just a machine that predicts the future. Like, right, on a very technical level, that's true. It is just a system that predicts sort of like the next few words in a sentence or like the next strokes on an image.
Yeah.
But what is interesting to us is that, well, what we're looking for is this sort of like emergent behavior where the optimal tool to predict the next few words in a sentence is to think about the sentence in maybe in a similar way that we think about them, and to sort of like develop these reasoning abilities.
Okay.
Because that would help you predict what comes next. And so like the idea is a bit that sort of like intelligence arises sort of like under the hood while you train to predict all this stuff and behave like a human, that you also like under the hood something emerges that really makes it intelligent.
Okay.
And for us, this is sort of like ultimately very hard to decide like when this will happen or where the sort of the line is drawn, because the system is very good at imitation.
Yeah.
And but that doesn't mean that there's not a potential for it not to imitate. It's just that it's very hard to decide.
Yeah. Okay. And one last misconception that I wanted to cover is the trustworthiness of AI. So what does it mean for AI to be trustworthy, and why is it important in today's context?
Yeah, I'm not really a big fan of the word trustworthiness.
Okay.
Because to me, it's like it's something where like that we encounter a lot when we talk to like say like more people on the policy side, politicians, and it's just something that sounds very good, right? You have this big new thing and you want it to be trustworthy, but the word is a bit lost all of its meaning for us, like in actual research, or it's hard to like make tangible improvements that make something more trustworthy.
Okay.
Like, of course, everything we do that makes the system better in some way, we think also makes it more trustworthy, or many things we do make it more trustworthy just because it's more reliable.
Yeah.
And maybe all the things that we do make it safer, also make it more trustworthy because then it really behaves more safer in everyday situations. But trustworthy by itself is very hard to grasp and very hard to, like for us, we really like we're always looking for things where we can really like define what we want and really make steps towards attaining some of these goals.
Okay.
And trustworthy is a bit of a buzzword where it's like, that makes sense, like we want it to be trustworthy, that sounds like a good idea, but it's hard for us to like act on that and really like define what we really mean by that.
Yeah.
Like for example, like something that enough comes up is like, yeah, we want the system to be explainable, for example.
Yes.
But what does that even mean? Like what, for example, like what does this mean to you that the system is explainable?
Well, it's accountable. It's.
Yeah, but is that explainable if it's accountable?
I think it goes hand in hand a little bit. So if a system is transparent, it's accountable, it's explainable, I think that all goes with the trustworthiness of a system. Yeah,
but what does it mean that it's accountable? Like does it mean that that I can hold it accountable for all the mistakes it makes, or that it doesn't make any mistakes, or like what does it mean for it to be accountable?
That if it makes mistakes, that it knows that it's making a mistake.
Yeah, that's fair. No, that's a tangible definition.
And how do we put that into, or effectively integrate that into a system, or how is that? Is it even possible? Is that doable today, or is that more of a futuristic aspect?
Yeah, I mean, this actually doesn't sound so hard.
Okay.
Like in the way that like often these systems like can run in a loop and can like sort of like. They can like, because for example, like I think the easiest way to think about this often are these chat systems, like because they just go text in, text out.
Yeah.
But for these systems, for example, like it can easily like read a text it has written itself.
Yeah.
And then answer questions about that. That even might be something like, is this completion harmful? For example, it will be there's an example in this way.
Yeah.
And where like the model can then make a second decision based on that. That's actually very doable. What's interesting though is that it is ultimately like I think by first approximation, I think the best way to think about it is that it's still a black box system where like the system makes some decision based on something that it has learned to do.
Mm-hmm.
And it can't really be accountable for that in the same way that we think accountability works.
Okay.
In the way that you can of course ask it about it and it can give you an answer about it.
Yeah.
Maybe like because it's trained a bit like to behave like humans, or because it has trained on similar processes. I could also ask you like how you made some decision, and you might tell me something, but what you tell me about how you made the decision might be unrelated to why you made the decision.
Okay.
It's actually that's a very interesting phenomenon, like in psychology, where sometimes people can, or like not sometimes, but there's these experiments that we can set up where someone takes a decision and then later builds up an explanation in their mind to rationalize why they did it.
Yeah. But that's not the case.
Which is like, it's sort of a black box system.
Yeah.
And here it works actually in similar ways, not necessarily because it's human, but because it's sort of a system, it works by similar like principles.
Yeah.
And it can give you some answer to like why I decided something, but it really wouldn't make you more happy than if you ask a human like why they picked red or blue on
True.
when they had to pick red or blue or something.
Yeah.
So it's not really like that's just would like do so much for us, I think.
Yeah. So in the end, what are we, the trustworthiness, you said that you don't like that word.
Yeah.
So how can we hold it in its way accountable, or how can we trust a system?
Yeah, I mean, I think the big thing also, like I think also described, like for example, that we talked a lot about over last year about this AI Act, is we don't really want the system itself to be accountable, but we want sort of like the application around it to be accountable.
Okay.
I don't really want to hold this my learned machine that predicts the next voids accountable.
Yes.
But I want to hold the company accountable that builds the system and sort of like sets it up in some environment. And that's really like where the accountability is set, like also in the AI Act, for example.
Yes.
And this is really was like how we think this should go, right? So
yes,
we can't really hold this machine accountable, but we can hold sort of like the company accountable that is supposed to like set up the incentives for this to work.
That makes sense.
And to be most safe. And that's really the only angle we have here.
Yeah. Well, speaking of the AI Act, so Parliament just approved it, I think last week or 2 weeks ago.
I think last week, yeah.
Yeah. And so I think that over the next few months, it's definitely going to be an exciting time for, the AI ethics, especially in the European, especially in Europe. So to you, do you think it is necessary to have, first of all, do you think it is necessary to have this AI Act?
I think it's a good thing to have around, in the sense that I think it's good to keep politicians thinking about this, and because I mean this is like these applications really are coming, this really is happening, and it's good to keep this in the conversation and to also make legislation that makes it safe, but also like thinks about this in the right ways. And so like I think just I think the discussion about it maybe was more helpful than the actual AI Act.
Okay.
Where because it brings up the conversation and it brings up like potential limitations or potential benefits, and I think it's good that these are being discussed also in a broader society.
Yeah.
I think the ultimate act, I think all sides were a bit unhappy with it, which I guess makes it a good AI Act so far, because I think we still are very early, and like from our side we don't really want to encourage, let's say, like some legislation that really constricts these companies too much.
Yeah.
But we also don't want to give them like a carte blanche forever. Yeah. And I think like talking to some colleagues who, for example, who are more in like AI ethics and AI safety, they thought this really was like not everything they wanted in the AI Act.
Okay.
And then we talked to the companies who are like, oh, we don't really like it. It like puts some restrictions on what we can do. Yeah. So I think it's a good middle ground right now. And it's also something like where like I think my main worry is that we legislate something, and then the way we legislate it becomes irrelevant in 2 years or something. Okay. And right now, I know that's like it's a bit of a wait and see perspective. Yes. Where I think it's good that maybe we can also make quicker decisions. Like maybe we can update this quicker in the future if something changes. But we do want this AI Act to be broadly just focus applications, and then we can change things around. Yeah. If something changes. And do you think it's good to have it just on a European level? For now, to keep it on a European level? I mean, I think it has some advantages that maybe this is like more my European perspective that it's good to make decisions together, and it doesn't really make sense to make separate AI Acts for the separate countries. And yeah, I think it's a big European strength to actually put this together and come together. I think this also makes it very hard to come to any agreement.
Yes.
as we might have seen, and which maybe is the downside. But for now, I'm okay with that.
Okay.
I'm just happy that this is being discussed. I think it's a good middle ground, and it won't really limit companies in the future.
Okay.
And it doesn't really limit academia in the future.
Okay. So speaking of the future, how do you perceive AI in the future? And where do you see it going? Where do you see the potential of AI?
I think there are two answers. So the first answer is like this near-term perspective. I think near-term, we do hope for some of these systems that can, especially with the systems that we've seen already, that we've seen working, like I think I've made this ChatGPT example 5 times, but that is like the biggest application that we've seen working so far, and we've seen it working for many people. I think there's a big opportunity there to commoditize that a bit more, and to make it really like a intelligence system that can help you on all kinds of, like especially like on sort of like office level tasks.
Okay.
Like because a lot of like things we do like to fill out forms and work on things, they aren't so hard.
They're tedious.
They're just very tedious.
Consuming. Yeah.
And I think there's an opportunity to at least help us automate a lot of these tedious tasks.
Mm-hmm.
Just with these near-term systems that we have right now, where we try to make them more reliable, and we still make them. We have some security concerns I described to you before.
Yeah.
But we're still like working to make the systems as useful as we can for sort of like some of these tedium stuff.
Okay.
That's sort of the near-term thing. I think long-term, we're still wondering about the limits of this whole thing. And that's what really drives us, is to see like, okay, what are the limits of artificial intelligence?
Mm-hmm.
And really, can we like get to some sort of general artificial intelligence with this current wave that we're sort of building out across academia and industry? If we get that, who knows what will happen? But we're excited to see how it will go, and so like how we can shape it to go in the ways we want.
Mm-hmm.
And I think like for us, it's important to think about like what values we bring along with us as we do this, and we hope to sort of like keep those together with what we do.
Okay.
But yeah, we'll see how it goes. I think that's really like the big, I think I've said this 10 times in this interview, but that's what makes it exciting, is that we don't really know like what the limits are right now, and we just keep on improving these systems and seeing what will happen.
And if you could choose one research focus for the future of AI that could really that could really benefit this world, so just like one specific point in AI for the future, what would it be?
Is safety too general?
Okay.
Yeah, I'm not sure if safety is too general of a point, but like for me, really, like safety is a big concern. Like especially near-term safety, things like systems that are really reliable, that will like everyday users use them, that it's transparent that it's a machine being used, but it's also transparent. But it's also that it's reliable. These are things that really motivate me a lot to figure out and to understand as these systems keep on changing.
Okay. So we talked a lot about the many aspects of AI, the fears and the concerns, is AI trustworthy or reliable, or and also like the future aspects of AI. So I kind of want to know, for you personally, are you more worried or are you more optimistic about AI? And overall general opinion, is AI good or is AI bad for the future?
I think I remain very optimistic.
Okay.
But I think I remain carefully optimistic in the way that I think there's work to do to make sure that we sort of get if we're on this future discussion, I think like it's very important like that we actually do the work to get to the future that we want to be in.
Mm-hmm.
And I'm still optimistic that this is achievable. But I don't think that's like maybe it's automatic or that it will always happen. But I do think it's achievable. And that's what motivates my optimism a bit.
Yeah, but we still need to stay careful.
Yeah, like we actually need to put in work to make this happen.
Okay.
In a safe and harmless way.
Yeah. Good to hear. And so you're part of the ELLIS Institute Tübingen, and you're embedded in Cyber Valley community. And so what does that mean to you? How do you benefit from the AI community that you are surrounded in?
Yeah. So what I think is really great about Tübingen, about Stuttgart, about this whole region as a whole, is that there's a large concentration of machine learning research like really around here, like on this hill, for example. I can just take a coffee and talk to some other great researcher about this. And like for me, that's really important. And it's really important to have close connections to a lot of research here, but also a lot of interesting companies, and to really have this environment and ecosystem where it's very easy to talk about these things and very easy to keep in contact with all the researchers and collaborate, and really just have this concentration of knowledge. And that's really why I'm here, actually.
Yeah.
It's like I probably wouldn't have come if it would be any other way.
So thank you so much, Jonas, for all of your input and sharing your knowledge with us today.
Yeah, thank you for having me.
And, remember everyone, the conversation doesn't end here. Let's continue the dialogue. Until next time, let's keep exploring and stay curious and embrace the ever-evolving world of AI. The future is literally unfolding before us, and I hope this podcast or this little interview has left you inspired and informed. And, so thank you very much for being part of the future with us.